Did you know that many common gold-plated items actually contain real gold? Things like gold-plated pens, watches, and electrical plugs all use small amounts of gold because it resists corrosion and conducts electricity well. Today, we're extracting gold from discarded gold-plated watch bands. First, we mix a gold stripping powder into hot water, then soak the watch bands in the solution while stirring thoroughly. After some time, the gold coating separates from the metal and dissolves into the liquid. Next, the bands are rinsed clean with water to make sure no gold particles remain on the surface. The gold-rich solution is then filtered and adjusted with an alkaline material to balance the acidity. After that, zinc wire is added to absorb the dissolved gold, and the mixture is left overnight for the reaction to finish. Once complete, hydrochloric acid is used to dissolve the zinc. The liquid is filtered again, and the remaining material trapped in the filter cloth is collected for refining. Then, sulfur compounds and heat are added to speed up the chemical reaction. Soon, sponge gold begins settling at the bottom. After cooling, the top liquid is poured away, and the remaining gold is washed several times with hot water until it becomes clean and impurity-free. Finally, the gold is filtered, dried, and melted at high temperature, turning it into finished gold. So, can you think of any gold-plated items you may have thrown away before? Did you know that many electronic parts actually contain real gold? Today, we're going to extract gold from this bucket of electronic waste. First, we add a gold stripping powder to the components, then pour in hot water to start the chemical reaction. At the beginning, you'll notice the gold color coming off very slowly. That usually means the parts contain a higher amount of gold. After soaking for a while, the gold coating completely dissolves into the liquid. Next, we pour out the gold-rich solution and rinse the remaining electronic parts with clean water to reduce any gold loss. Then we filter the liquid to remove impurities. After that, we add zinc wire and an alkaline material to adjust the pH level of the solution. Now comes the waiting part. We let it sit until the yellow color disappears completely. Once the liquid turns clear, it means the zinc has absorbed all the gold from the solution. Next, we pour away the remaining liquid and add an oxidizing agent to dissolve the zinc. What's left in the container is raw gold with a lower purity level. Now we transfer it into a beaker and add a refining agent. Using high heat, we remove the remaining impurities. Soon, you can see sponge gold settling at the bottom. After that, the sponge gold is placed into a titanium bowl and heated to remove all moisture. At this point, it's finally ready to be melted at a very high temperature. And this is the final result, a bright, shiny piece of gold. So, what do you think? Did you ever realize these old electronic parts contained this much gold? Can you believe there's actually gold inside old fountain pen nibs? Today, I picked up a whole batch of used pen tips from a recycling station, and we're going to extract the gold from them. Let's get started. First, we add a gold stripping powder into a bucket and mix it with hot water. Once the solution is ready, we pour it over the pile of pen nibs. And just like that, the gold-colored coating starts coming off almost instantly. The reaction happens surprisingly fast. Good thing we collected a huge amount of nibs, otherwise the final gold wouldn't even be worth seeing. After all the gold coating has been stripped away, we pour out the liquid. Next, we add a balancing agent to adjust the pH level of the solution. Then we drop in some zinc wire, which will absorb the dissolved gold from the water. After a while, you'll notice the zinc wire slowly turning black. That's how you know the gold has successfully attached itself to the zinc. Once that's done, we remove the zinc wire and add a dissolving solution to melt the zinc away. What's left behind is raw, unrefined gold. We heat it at a high temperature first to improve the purity, and this is what the gold looks like after heating. Now for the final step, using a torch to fully melt the gold down. After the melting process is complete, we're left with the finished product. Pretty surprising, right? Who would have thought that ordinary old pen nibs could contain this much gold? Did you know that a lot of electronic waste actually contains real gold? Since gold conducts electricity well and doesn't corrode easily, many electronic components are coated with it. Today, we're going to extract gold from these gold-plated pins. First, we prepare a bucket of hot water and mix in a gold stripping powder. Then we pour the gold-plated pins into the solution and stir everything thoroughly so the chemicals can react with the gold coating. After soaking for a while, we filter the liquid out. By this point, the gold color has completely disappeared from the pins, meaning the gold is now dissolved in the solution. Next, we add an alkaline material and zinc wire into the liquid. After mixing and letting it sit, the zinc begins absorbing the gold from the solution. Once the reaction is complete, we pour away the clear liquid and keep the zinc and sediment at the bottom. Then we rinse the zinc several times to remove impurities before using another chemical process to dissolve the zinc itself. After the reaction finishes, we pour off the top layer of liquid. What remains at the bottom is sponge gold, raw gold still containing moisture. Next, we heat the sponge gold to dry it into gold sand. Finally, we melt the gold sand under extremely high heat, and little by little, solid gold begins to form. Hard to believe, isn't it? These small electronic parts that most people ignore can actually contain real gold. Did you know that many old circuit boards people throw away actually contain real gold? Especially the boards used in computer memory sticks, the thin gold-colored layer is actual gold. Today, we're going to extract it step by step. First, we soak the circuit boards in hot water for about an hour. This helps the other materials absorb water and separate more easily from the gold. Next, we mix a gold stripping powder with hot water and pour it over the soak boards while continuously stirring. Slowly, the gold color disappears from the surface, which means the gold has moved into the solution. Then we filter out the liquid, adjust the pH level, and place zinc strips into the solution. The zinc absorbs the metal particles, and after a short time, the strips begin turning black. This part takes a little patience. Once the process is complete, we pour away the extra liquid and keep the zinc and sediment at the bottom. After that, we add another chemical solution to dissolve the zinc and impurities, then rinse and filter everything several times to remove the remaining acids. After most of the liquid is filtered out, it's time for the final purification step. We add a refining agent and heat the mixture at a high temperature until the gold settles at the bottom. Finally, we melt the recovered gold with a high-temperature torch, and little by little, solid gold begins to form. Hard to believe, isn't it? Something most people casually throw away can actually contain real gold. Most people throw old SIM cards away without thinking twice, but what many don't realize is that these tiny cards actually contain real gold. Today, we're going to extract gold from a pile of old SIM cards. First, we prepare a gold stripping solution and soak all the SIM cards in it. Then we rinse them over and over, and little by little, you can actually see tiny gold particles falling off. After enough washing, the gold color completely disappears from the cards. Next, we pour out the gold-rich solution and add an alkaline material to balance the pH level. After that, we place zinc wire into the liquid and continuously stir it. The zinc slowly pulls the gold out of the solution. Once the zinc wire turns dark, that's a sign it has absorbed most of the gold. Then we remove the zinc wire and place it into another solution that dissolves the zinc itself. What's left behind is a dark material containing raw gold mixed with impurities. After filtering out the black residue, we add a sulfur-based chemical and heat it at a high temperature. As the liquid heats up, the impurities evaporate away. Then we add a reducing agent, which separates the gold from everything else, causing it to sink to the bottom. Finally, we filter out the sponge gold. At this stage it's still wet, but once it's melted under high heat, it turns into real, shiny gold. So next time, don't throw away your old SIM cards so quickly. They may look worthless, but enough of them can turn into real gold right in front of your eyes.